Every time you flip a light switch, you're tapping into one of humanity's most extraordinary, invisible, and surprisingly fragile machines. It's a vast, interconnected web operating on a constant knife edge. So what keeps it all running, moment by moment, and what makes this incredible system crash? The grid's secret isn't just power, it's balance. Every moment, the total amount of electricity being generated must perfectly match the total amount being consumed. Not almost, but precisely. This constant equilibrium is measured by the grid's frequency, a rapid pulse, usually 50 or 60 times per second, depending on where you are in the world. Think of it as the grid's vital heartbeat. If demand suddenly rises, say everyone in a city turns on their air conditioning, generators instantly ramp up output. If demand falls, they slow down. Highly sophisticated control centers constantly monitor hundreds of thousands of data points, predicting usage patterns and directing power plants to adjust. Highly sophisticated control centers constantly monitor hundreds of thousands of data points, predicting usage patterns and directing power plants to adjust. This isn't a static system, it's a living, breathing entity with millions of micro-adjustments happening every single second. This isn't a static system, it's a living, breathing entity with millions of micro-adjustments happening every single second. But what happens if generation and demand fall out of sync? If generation can't keep up with demand, the grid's frequency drops, too much power, and it rises. Even a tiny deviation from that perfect 50 or 60 Hz can be disastrous, damaging equipment and threatening the entire system. And it's not just about matching the amount of power. Every single generator, from huge nuclear plants to backyard solar, must operate in perfect synchronization, like an enormous invisible orchestra playing in unison. This delicate balance explains why power outages occur. It often starts with a seemingly minor incident. A lightning strike taking out a single transmission line, a piece of equipment failing at a substation, or even a tree branch brushing against wires. When one part of the grid goes offline, the electricity it was carrying doesn't just disappear. It reroutes, surging into other lines and generators. These remaining components suddenly become overloaded, like a single highway lane trying to handle all the traffic from a closed 10-lane freeway. This overload triggers automatic safety mechanisms. To prevent catastrophic damage, these systems deliberately trip, shutting down components to protect them. The paradox is that this protective action, while necessary, can cause a chain reaction, known as a cascade or blackout. More lines trip, more equipment overloads, and the darkness spreads. Not because the grid failed, but precisely because its safety features kicked in. Managing this invisible machine is only getting more complex. Integrating intermittent renewable energy sources like solar and wind power, which fluctuate with weather, adds new layers to the balancing act. Our aging infrastructure faces growing demand and extreme weather events. The challenge is to evolve this vast, dynamic system, ensuring its delicate balance can withstand an ever-changing world. The electrical grid is a marvel of constant dynamic balance and interconnected fragility. How will we continue to adapt this invisible machine to power a demanding future?